Hi all, this is a video about graphs of functions. So we're going to go through some of the vocab that goes with graphs of functions and look at the specific picture and see if we are clearly understanding these things or not. All right, so we're going to start with increasing, decreasing. So looking at this graph, the function, let's just look at the top one. We're going to add stuff to these later. That's why it's showing up 3 times. The function is increasing if its y values get bigger as you move from left to right. So definitely increasing on this little stretch right here until we get to this top point, and then it switches for a bit, and then definitely increasing from this bottom point all the way until the graph dead ends. And let's assume this is an open circle. I don't know why I didn't make it that, but let's assume it is. The graph dead ends there as opposed to continuing. So this function looks like it increases for x's between 0 and 1 and x's between 2 and 4. So as usual, you can choose inequality or interval notation. It's up to you. So let's try interval. I want to start at 0, stop at 1. And I would say, again, I'm not giving you really precise definitions of these things. You'll get those when we get to calculus. So for now, it's just this general idea. But my opinion would be that you should give those both round brackets. I'm not going to get crazy picky about that, I promise. But I would say, especially right here, right at this point, x equals 1 is where it switches from increasing to decreasing. So there's a little flat spot there. So I would say it should be doing neither one. This one's a little bit more funny. It's definitely increasing on this side, but it dead ends. So again, I won't get crazy picky, but I would just default to giving those some open brackets for now until you get a little bit better definition. And then we want to combine this with all the x values between 2 and 4. And again, I would just default to giving, round brackets to those things. The 4 is kind of a funny one, but definitely at 2, it's decreasing on one side and increasing on the other. Right where it switches, we would say there's a little flat spot and it's not doing either. Okay. Decreasing. So decreasing is the little section that I skipped right here in the middle. The function is decreasing from x equals 1 to x equals 2. Let's go ahead and use inequality notation for that. So I would say for x is between 1 and 2. And again, I would just leave off the equal to because right at the top and the bottom of that interval, there's a little flat spot. So I would say it's not increasing or decreasing. Okay. Where does f have local maxes and mins? So these are at the points where we switch, actually. And again, remember the idea is if you think you have a local maximum, you're claiming that point has the biggest y value of any points nearby. So I think this y value is bigger than all the y values nearby. If you want to make sure you're right and really convince yourself, you should be able to draw a circle. You can make it as small as you want, but the point has to be centered in the circle. And the circle should not catch any y values that are bigger than the one you're claiming is the maximum. So f has a local maximum at x equals 1. I would also say, again, I haven't given you a very precise definition, but using what I have given you, I would say 4 fits the definition, x equals 4. There are no y values bigger than that. So 1 or 4 look like local maximums. And then local minimums. Looks like we have one right here. Again, if I draw a little circle, that is the smallest y value in that circle. And also at the end point, x equals 0, I get a smallest y value. So at x equals 0 or 2. Oh, I'm remembering something that I wanted to say. So it's very deliberate that I'm answering all these questions by giving x values. Unless a question really specifically asks you for y values, it's always better to answer with x values because that's unambiguous when you're talking about functions. So just so that you see what the problem could be, if I ask you when f is increasing and you describe that using y values, you say from y equals 0 to y equals 2, you're actually describing all of the graph up to this point. So this entire up, down, up has y values between 0 and 2. So because outputs do not have to go with unique inputs, you could describe an interval using y values and actually be describing multiple intervals. So always best to answer with x values. Right now, off the top of my head, the one time I can think that I would answer with y values is if I was asked for the range, because that's specifically saying what y values does your function take on. So otherwise, I think I just about always answer with x values. Okay, so similarly for concave up, so concave up, this, I'm just wanting you guys to get good at looking at this bend and seeing when you have the upward bend or downward bend. So upward bend should look like smile, downward bend should look like frown. So here, I see bending downward. It's pretty straight over here, but definitely bending downward through here. And then somewhere in here, it looks like it switches to an upward bend. So this is looking concave up. And then it seems to switch back to concave down, maybe not even concave at all, maybe just straight right here. So something can be a perfectly straight line, in which case it doesn't have concavity. But let's just say that stays concave down. So concave up appears to be, and again, you have to estimate this, it appears to be concave up from about 1.5 to about 2.5, roughly. So let's go 1.5 to 2.5. So that's how it would look if you use interval notation. Concave down, let's go ahead and use inequalities. There were two segments that looked concave down. Again, it's kind of questionable at the ends. It could straighten out completely. So if that's what you think's happening, fine. Block it down a little bit more for me. But I'm going to say I have that downward bend all the way from 0 to 1.5. So 0 to 1.5. And just like with the increasing, decreasing, I would just default to giving it round brackets for now until we have a better definition. We don't want to get too picky with it, but that's my advice. And then we decided it also switches back to a downward bend at 2.5 and holds that until we get to 4. 2.5 to 4. So again, when you're answering these questions, answer with x values so you're not potentially giving an ambiguous answer. Where does f have inflection points? Okay, so that should be right where we decided that these things were changing bend. That's what an inflection point is. So the bend changes at 1.5 from concave down to concave up, and then at 2.5 from concave up to concave down. So I would say at x is approximately 1.5 and 2.5. That's estimated. That's fine. Just be careful. Some people want to put them at the maxes and mins, and that would definitely be wrong. At the maximum, it's definitely concave down, and at the minimum, it's definitely concave up. Okay, and then the last few parts of this are all about symmetry, and this again is just kind of emphasizing that visual. Can you look at a graph and spot when you have even symmetry, odd symmetry, some other symmetries as well. I threw in a different one here just to make sure that we're comfortable with the wording. Okay, so if I want to make the top graph an even function, even functions are symmetric across the y-axis. So if I pick this graph up and fold it at the y-axis, the two halves should match up evenly. So basically I want a mirror image over on this side. And you can do this point by point a little bit. So I have kind of the general idea in my head. But I can say if I have the point 4, 4, then straight across here should be the point negative 4, 4. If I have the point 3, 3, then straight across I should hit negative 3, 3. If I have the point 2, 1, then straight across I should hit negative 2, 1. 1, 2, straight across I should hit negative 1, 2, and then 0, 0 will be where the two meet. So matching up this general shape that I have is bending down and then up and then down, and there is what appears to be an even function. Okay, so for part G, we're supposed to work on this middle graph and decide what we need to add to make the middle graph an odd function. So odd function, again, you can picture picking up any one quadrant and flipping what you've got across both axes, and you should land back on your graph in the opposite, like diagonally opposite quadrant. You can also picture this as rotational, so if you spin it 180 degrees, it should land back on your function. So point by point, it's symmetric through the origin, which means if you have a point 4, 4, straight across through the origin would give you a point -4, -4. Or again, you could do it as flip, flip. So if I flip over here, -4, 4. If I flip again, -4, -4. 3, 3 means I should have another point at -3, -3. So opposite x, opposite y. 2, 1 should be -2, -1. 1, 2 should be -1, -2, and 0, 0 is where they should meet. I should say right now that because this function hits the y-axis, the two pieces touch. If this function did not hit the y-axis, the two pieces to get the symmetry would not actually touch in the middle, and that's fine. Same thing here, because this function hits the origin and it's symmetric through the origin, the two pieces will actually meet at 0, 0. But if this graph did not hit the origin, then the two pieces we draw would not meet in the middle. Okay, so let's see if we can get this bent right. So if we're flipping this way, so it's going to go like this, this, and like this. Okay, so that is a rough sketch of what we would have to add on to that function to make it odd. The last one is nothing too tricky, but I want to make sure people aren't thrown off by the wording. We should be able to spot symmetry across any vertical, horizontal line, any line really, but especially horizontal or vertical lines. You'll see a lot of vertical here because if you have symmetry across a horizontal line, then your graph is automatically not a function. So this one I'm asking you to create symmetry across the line x equals 4 by adding to the graph. Recognizing that that is the equation for a line is a really helpful start. X equals 4 is this vertical line right here. If I want to create symmetry across that, I can see that since the graph hits the line that I'm trying to create symmetry across, the two halves will meet here. I should have a point directly across from 3, 3. It'll end up being at 5, 3. This one at 2, 1 should come straight across here. So basically you want to go equal distance out and have a corresponding point. This one out here at 1, 2, so it's 3 out. So we go 1, 2, 3 out, should have a y-coordinate 2. And then if we had 4 out, we have a y-coordinate 0. So something like this. So I really am only looking for a fairly superficial knowledge about symmetry. I want you to know what that tells you about the way a graph looks, and I want you to be able to think a little more carefully about what that means point by point, and I will be happy. That's what I'm hoping for. Thanks for watching.